All right, 109, we have a lot of different topics in this one. Primarily here, we have, I want to talk a little bit about conductor types, some common voltage systems, and then some derating factors. Your derating factors is going to be the big one here. Kind of save that for last at this point. So I just want to say a little bit about conductor types. I'm going to focus on one in particular. So when I talk about conductor types, we're really talking about different types of insulation. The book does a nice job of going through these, but I just want to pick out one that's sort of the most common and maybe a little bit misunderstood. But that's your THHN/THWN. So that's actually generally going to be one wire. One wire will have both of these ratings, THHN, THWN. You'll kind of hear it regurgitated. I don't know if a lot of people really know what it all stands for, so I want to break that down because every one of these letters means something here, right? So again, this is one type of wire. It has both these ratings depending how we use it. So let's look at the THHN side first. The T stands for thermoplastic. That's just the material it's made of. That's not terribly important to you. This next one is though, the HH. Depending who you ask and how you think about it, the HH either stands for high heat or it has two additional heat ratings. And I'll explain what I mean by that in a moment, but keep that in mind when we get to some of our tables here. So essentially, you know, when we start, we have three temperature ratings: 60 degrees Celsius, 75 degrees Celsius, 90 degrees Celsius. So we start at 60, we get one additional heat rating that gets us up to 75. We get one more heat rating that gets us up to 90. Either way, however you look at it, that puts this wire type in the 90 degrees Celsius column when we look at some tables here that we're going to look at in a moment. This HH, we can only apply it if we're in dry locations, okay? And sort of there's what I mentioned. We go from 60 to 75 to 90. But the key there is we got to be in a dry location. We'll talk about what happens in a wet location here in a moment. Then the N stands for nylon. There's an overall outer nylon covering. Again, that's not, terribly important for you guys. But let's look at the THWN side. Again, the T is thermoplastic. The H now is telling us we only have one heat rating. So we're going to go from 60 to 75. Reason being now, we're essentially trading out one of these H's, right, up here for a W. So if we're in a wet location, we can only count that as part of the 75 degree column of our table, which again we're about to look at. So essentially it knocks it down by one heat rating basically. So we're start at 65, we can now only go to 75 if we're in a wet location. And then of course the W stands for wet location rated. And again the N is nylon. So I don't even necessarily need you to memorize all that. My point of that is I want you to know A, every letter in every insulation type has a meaning, but B, when we talk about THHN, THWN, it's not two different wire types, it's one wire type, it just depends on the use. And that's the most common. There's several others, we could have a whole class on it, I'm not going to do that. So, the only thing to keep in mind, as I mentioned, we're going to look at a table. Keep those, the letter nomenclature in your mind until we see that table. Before we do that, I just want to get out into the open. We have some common voltage ratings that we talk about. I always felt like this was glossed over and you almost had to pick it up on your own as a young apprentice, but it's very important to know and to know early on. So we have three that I'm going to talk about. We have 120/240, we have 120/208, and we have 277/480. So depending on the building, you could have, generally 99% of the time, you're going to have one of these three voltage system ratings. Okay, so what does this all mean? So first of all, let's look at the 120/240. It's a single phase voltage system. What that means is there are two hots instead of three hots, which we'll see in a three phase. Why don't they call that a double phase? I have no idea, but a single phase system or a single phase circuit, when you hear that, it means we are using two hot wires. Okay, if we take a voltmeter and measure from one of those hots to our neutral or ground, we will read 120, or the first number to the left of the slash. If we read from hot to hot, between our two hots, we should read 240, or the number after the slash, right? And typically this is residential. In all of your homes, this is the voltage you're dealing with, unless you have like an apartment situation or anything like that. So this is almost always going to be residential. You do see it cross over into some commercial stuff here and there. Most commonly, that's your residential voltage system. So 12208, this is now a three-phase voltage system. What that means is we now have 3 hots and a neutral. Okay. If we read again from hot to neutral, we would read 120. From any hot to the neutral or any hot to the ground, we get 120. If we read between any 2 hots, we will read 208 volt. You may be wondering why it's not 240 again. That's a very long answer, and you will spend a lot of time talking about it in year 2. This is a lot more common in commercial buildings, banks, stores, things like that. And then sort of the third one to talk about is our 277 480. Again, that's a 3-phase system, meaning we have 3 hots plus a neutral. If we read from any hot to neutral, hopefully you're seeing the pattern. We will see 277, or the left hand before the slash. If we go hot to hot, we get 480 from any one hot to any other hot. And again, you're going to see this in commercial and even into more industrial applications. You're going to see your higher voltages because maybe you have larger equipment, whether that's cooking equipment, whether that's industrial processes, things like that. Again, you'll see this one on residential. You see these guys on your commercial and industrial jobs for the most part, right? So now here's kind of one of the bigger topics here. So I want to get back. We talked about conductor types, and we're going to look at how that relates to conductor ampacity here. So first of all, what's conductor ampacity mean? It's defined as the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. So there's that temperature rating once again. So all this stuff boils down to one table in the NEC. So if you're going to remember, I'm not going to ask you to memorize the NEC, but there are a few things I'm going to highly suggest you do commit to memory. One of them is this table. Not the whole table, but the table reference. Table 31015B16. Used to be called 31015. That was nice. Now they changed it. It's 31015B16. This is a very important table. You're going to spend a lot of time looking at this one. So I want to point out a few things here to you. First of all, along the left, we see all of our wire sizes listed. Right? Notice we actually go all the way up to 2000 kc mil. So we have 18 gauge, 16 gauge, 10 gauge, up through 1 gauge. Right? So that's these guys here. Then we come down to 1-aught, 2-aught, 3-aught, 4-aught is the way you say that. And these go from small to big, by the way. Then we get 250, 300, 350. What are these? It's actually called kc mil. So we'd say 250 kc mil. Some guys still say MCM. It means thousands of circular mils. So K is the K is the metric prefix for 1,000. So that's how we see kc mil. Some guys would say MCM. M is the Roman numeral for 1,000. K is the metric prefix for 1,000. You see where that comes from. kc mil, MCM means the same thing. So here's all your wire sizes along the left. Along the top, we see these temperature ratings. This is what I was mentioning with insulation types. We have 60, we have 75, we have 90, we have 60, 75, 90. So, again, you're going to see all various wire sizes, various insulation types here, and what temperature column they are approved for, right? And that'll come into selecting how many amps our wire can carry here momentarily. Notice then down here, as I said, here's your insulation types. Why do we see it kind of duplicated? Well, this section of 3 is for copper, right? And then our next section of 3 is actually for aluminum, or they say aluminum or copper clad aluminum. I've never seen that. It's always copper or aluminum. And they do repeat the wire sizes over here. That's just for convenience, no big deal. So these 3 are copper, these 3 are aluminum. Okay, so what you're going to do generally if somebody says, hey, how many amps can a number 2 carry, a copper number 2? Okay, 9 times out of 10, for theory's sake, they're not going to tell you the insulation type. And your book goes into a longer explanation of this, but as a rule of thumb, you're going to default to your 75-degree column unless specifically stated otherwise, if you're just simply selecting a wire size to go with an ampacity. Oh, I got a 100 amp circuit. What size wire do I need? Okay, well, we're going to come down here and say, okay, here's 100 amps in the 75-degree column because we didn't specify otherwise. So we're going to default to 75 degrees most times, unless specifically stated otherwise. One exception to that is when we get into what they call derating factors. Okay, so what do we mean by this? We have to actually derate our wire, so it's not rated for as many amps as the table says it is. So why would we ever have to do this? Why would we want to do this? Well, we don't want to do it. We have to do it. There's two key reasons why you're going to do this that we're going to talk about. Number one is if you have more than 3 current carrying conductors in a raceway. Reason being, conductors build up heat. When there's more than 3, they theoretically build up enough heat to be detrimental to the amount of amps that conductor can carry, right? And then the second reason we're going to look at, oh, I'm sorry, so to do that, we're going to look in 310.15b3a. It's actually one page before 310.15b16. So there's actually a snippet of that. Again, just flip the page back one in your code book from 310.15b16, and you'll see this guy. Second reason, if we have high ambient temperature, okay, you're going to check, again, it's on, I believe, the same page or one page back, 310.15b2a is going to tell us how to handle that, and that's what this guy looks like. So I'm actually going to end this video. I'm going to put up another one. We're going to look at some examples of how to do this. Okay, so I'll see you guys in the next video.